We are recording with screen support this time. Someone noticed that the recording from last Thursday was apparently just me like standing here talking to you, and who wants that? So I just somehow, I don't know. Anyway, so we had a video on pretty much the exact same thing that I showed you, so I don't think there's any huge, especially not for you all, because we're probably here, right? So anyway, hopefully that won't happen again, but if it does, I'm perfectly prepared with my backup lectures. So let's go ahead and get the sort of mood music off. As promised, I was kind of challenging myself to show you all like a Rhino project per session on Rhino. And so this is a project that I did a couple of years ago for, it's actually a proposal, and I could probably teach a whole class on proposals that I've done that have never gotten selected, because that's like a huge part of being an artist, right? You have a ratio of like, you know, things that you send out for submission, and then things that actually get picked, right? You don't get picked to do like a large public art commission every day. So if you're doing this type of work, you're probably preparing a lot of proposals and then not getting any of them, or getting very few. And even if you're getting very few, you're actually doing really well, because sometimes, you know, hundreds and hundreds of people will apply for these opportunities. So what I ended up doing here is basically recreating these. There's a public art program in Philadelphia in a castle. Oh, it looks like a castle, but it's not a castle. It's a Jeremy Bentham-style prison, actually, from the 1850s. And they let artists in to basically, you know, put art in these jail cells. And so it was probably like one of the projects that I didn't do that I really was excited about, just because the environment was so creepy. If you can imagine a sort of like prison that stopped operating in like the 1930s around the Al Capone era. He was actually a resident there for almost, I think, 23 years. And so anyway, we were sort of, me and my collaborator were interested in doing this work that had to do with the Innocence Project, where people are sort of finding out, you know, many years past a crime, that people are actually, you know, not guilty, and they're using scientific evidence to do that. So I generated this big chandelier, and I don't think you can see it on this. I think I actually did it in post. I strung a bunch of rhinestones from it that looked like they were in the form of a DNA molecule. And so anyway, this was the work. It probably took me, I would say, well, we actually went there for a site visit to actually look at the space, me and my collaborator, and then it probably took me another couple of weeks to do this. So is it worth it? Is it not? Gosh, I don't know. I mean, I have gotten some of these projects, and then it, you know, it makes the next 10 that I don't get worth it. So yes, so a note about rejection. It happens to everyone. So today we are going to get into Rhino in a kind of different way. We're going to talk about some kind of broader concepts related to, sorry, I'm just checking the recording to make sure it's working. So we're going to look at some broader concepts related to 3D modeling, and then we're going to kind of try them out in Rhino. And then I'm hoping to sort of pivot about halfway through the session and talk about how to make things with freeform curves, which is kind of edging into the next assignment. So we spent some time last week really talking about how the Rhino interface works. We'll be talking about that the entire time we're using Rhino, because it's kind of just an issue. Not maybe an issue, it's something, you know, that you have to learn. And then we also talked about the ideas of using solids and modules for your Modules Galore assignment. So what we want to talk about is just kind of a bird's eye view look at 3D modelers. So it's possible that maybe y'all have heard of some of the 3D modelers that are out there on the market right now. They're apps, pieces of software that you can choose to use. Of course, I don't think Rhino is maybe necessarily the most popular one. It's been around for a really long time. But as I said, one of the reasons that we chose Rhino is because it's a little bit lower on the cost and tends to be a little bit better for what we do as a department. Within the spectrum of 3D modeling software, there are sort of these core technologies. And one of them is called NURBS. You may hear the phrase NURBS. You may hear me repeat it a couple of times in different contexts. And NURBS is really just kind of a way of talking about the underlying technology that Rhino is using. Meaning that, well, what is a NURB? What is a NURB? It's kind of like what I used to call my little brother when he was like being annoying in the car. No, it's not that. A NURB is it's basically an acronym. It's a non-uniform rational B-spline. Now, that doesn't tell you much, but what it should tell you, the key word there is spline. That's really the key. And a spline, I might actually, no, I won't. I was going to draw this out on the board, but I have it right here. A spline is really a line that is being affected by what are called anchor points or control points. Now, where do splines come from? Interesting history that you don't need to know, but this is kind of what we love here. So splines actually come from the tradition of shipbuilding. And so just to kind of honor that tradition today, I'm gonna make a boat in Rhino. So yeah, no joke. When the Vikings used to, or anybody else for that matter, used to make ships out of wood, they would set up these systems that would basically use blocks to push the wood in one direction, and wood being somewhat bendy, the wood would eventually comply with that. And so that sort of architecture used to make wood curved is called a spline. That's your fun fact for today. So now, of course, everything in computer world is, sort of explained by its relationship to the physical world. At least a lot of things are. And so then when people sort of took on this project of making freeform curves, they decided to kind of borrow from that physical world approach. And so what you get are basically, as you can see in this document right here, or this slide, what you get are these sort of malleable freeform curves. So that, in a nutshell, sums up NURBS. There's also another type of 3D modeling out there called polygonal modeling. I'm not going to talk too much about the sort of use cases for all of these different models. I just want to kind of go through them, and we'll talk about the use cases in a couple of slides. So polygonal modeling is really what is going to dominate the so-called cinematic effects software packages like Maya, 3D Studio Max, Cinema 4D. There's a whole bunch of them. There's like a whole, Houdini. There's literally probably at least a dozen of these sort of software packages out there. There's also another method called surface subdivision modeling. Back in the old days, 10 years ago, there used to be some apps that would do surface subdivision modeling, which is kind of a somewhat exotic kind of mathematical approach to creating 3D form. But now, I think today it's something that you would see mostly in plugins. So I know there's a plugin for Rhino that does surface subdivision, but I'm including it on this list because it's a very technologically distinct way of creating 3D stuff. It's distinct from NURBS, and it's also distinct from polygons. And then we have the last category, which is a category that if any of you are over in the College of Engineering, you're probably already familiar with. That would be constructive solid geometry. So constructive solid geometry really kind of dominates the AutoCAD apps. So if you're looking at learning AutoCAD, like Sensu Stricto AutoCAD, or any of the other AutoCAD-related apps, which of course there are a ton, like Inventor or, I don't know, Recap. I mean, there's so many of them now. Pretty much all of those at their sort of core are going to use constructive solid geometry. And it has a lot of benefits for people who are building stuff. And when I say people who are building stuff, I mean specifically people who are building stuff that follows kind of a formula. So architecture, for example. In architecture, you may have noticed or not noticed that this floor is like pretty much like almost every other wooden floor you've ever seen, right? It has an even spacing of slats, and so on and so forth. Well, so in something like, in an app like AutoCAD, you could basically take the description of this wood floor and then basically like use it as just a conceptual object rather than having to kind of define every little part of it. And then if you change the wood floor later, you can change every single slat in the wood floor. So for materials that are, if you're working with physical world materials that are predictable and standardized, constructive solid geometry is totally awesome. So that's why it dominates the architecture industry, because I can have a model of like a house, let's say, and maybe I wanted to build the house with like 2x4s, which is a perfectly reasonable thing to do, right? Like some standard size of lumber. And then my supplier calls and says, oh, have you heard about this like shipping, debacle and, world shipping shortage? We can't get those. I can go into my design and I can say in code, hey, AutoCAD, I would like to have all new lumber, and I want you to adjust the size of everything else that this lumber touches. And so I'm sure you can imagine that's like magic. It's like really powerful. But there's a lot that constructive solid geometry doesn't do, and it really only works well for sort of relatively simple forms. There's a lot of things that you can't do with it. So anyway, excuse me. So that's just kind of a thing. Now that we've gone over these 4 things, I might point out that they matter less than they used to, but I think it's a really good idea to kind of know what you're getting yourself into. So just to kind of clarify, in Rhino, in this class, we're using NURBS. The only time that you might cross over into one of these other methods is if you export your file for a 3D print. Does Rhino have the ability to work in polygons? As a matter of fact, it does. And I have to tell you, as a longtime Rhino user and user of other apps that work well with polygons, it's not very good at it. And my sort of theory on that is like, it's sort of like how Photoshop thinks that it can be Adobe Illustrator, right? It's added, over the last 10 years, Adobe Photoshop has added in a lot of functionality from some of the other Adobe apps. And it's kind of okay, but, I have those other apps, so why would I do that? Like, why would I do something that I could do in another app in Photoshop? So the 3D world is kind of, experiencing its own version of feature creep and product sort of migration. So you'll see that in 3D. A lot of 3D packages now purport to kind of do it all. And I pretty much, as in mostly all things, but particularly with 3D software, I would say don't believe the hype. So yeah, this is what a NURBS in 3D would look like. So this is a NURBS surface. And you can see it's still controlled by those splines and anchor points, but it's doing that in kind of a 3D way. Yeah, let's talk a little bit about what's good for what. So we're doing Right now, in this class, we're pretty much modeling for the screen. So that's a perfectly legitimate reason to use NURBS. What are NURBS good for? Well, definitely I would say NURBS are good for anything made to be part of the built environment, short of maybe an actual building. Then you should use AutoCAD. Like, if you're an architect, basically. But if you're just like making stuff, building stuff, designing stuff, NURBS is the way to go. Another thing that NURBS are sort of like legendary for, and definitely is sort of their main function, is that they're ridiculously accurate for smooth surfaces. And I'm going to demonstrate why in a few seconds. So what are polygons used for? What are they good for? Polygons are really good for rendering quickly. And I'm going to say something that is kind of like a little cheeky here, but that's about the only thing they're good for. No, that's not really true. I mean, they're great for, obviously, for games, for video effects, basically anything where you need the computer to mush through the sort of 3D data really quickly. And so that's where you see polygon-based models, is out in, certainly the video game world is sort of rife with high and low poly models. You also see, the cinematic effects world. That's all rendered with polygons because it has to be super fast. And then another place where we're seeing polygons sort of in practice are with 3D scans. So any sort of 3D scan data is almost 100% going to be in polygons. A question that I get a lot about 3D scans from students is, how do I take a 3D scan and then turn it into NURBS? Wouldn't that be cool? The answer is no. You don't. You can't. So you can go from NURBS to polygons, but you can't go from polygons to NURBS. And now that's not 100% true. I mean, I have worked from 3D scans and sort of laboriously converted them to NURBS, like by actually drawing on them. But that's starting to sound a lot like work. So I won't, maybe don't say never, but it's not a fun thing. We will make a polygon model from a NURBS model today, just to kind of show you the difference there. So before we jump into like the difference between polygons and NURBS, I want to just recap. I put this on a slide so it would be here for the final exam. I put this on a slide so it would be here for the final exam. So this is kind of one of the things that we touched on in the last two sessions, is this idea of the hierarchy of form in Rhino. So this should be a little bit of a review, but it's this idea that in Rhino, you're starting with a line or maybe a point. There's a surface, which is sort of like a flat, filled-in shape, and then you have an open poly surface, and then a closed poly surface, aka a solid. So we'll be reviewing that today, hopefully as well. So let's jump into Rhino. Excuse me, I don't know why I'm opening. So let's talk out the hierarchy of form, and we'll also sort of talk out some of those format issues that I brought up earlier. So I'm going to just kind of jump into my 4-port layout here. I can start by, drawing a line. We all know about the line. Sort of, I could start with just a flat line or a polyline. Actually, I think I'm going to go ahead and jump straight into the curve, just because it'll get things done a little bit faster in general and curvier. So I'm going to just go ahead and make a single line here. And you can see right now my setup is in ortho, so I'm constrained. That's kind of okay. Hey, pro tip, if you hit the Shift key, it will temporarily turn off ortho. which I actually tend to keep mine like that because I work a lot with right angles. If it doesn't seem important to you, then don't worry about it, but it's just one of those things that you might want to. So if I hit the Shift key, it allows me to kind of go anywhere. And I'm going to sort of just draw a couple of points. The curve tool can take some getting used to in Rhino. As you can see, you're actually drawing the control points. You're not drawing the points on the line themselves. So you kind of have to anticipate where the line is going to go. And it's not super hard. It just takes, I think, a little bit of getting used to. So if you were thinking about maybe, making some line drawings just by yourself, that's probably a good idea. So this looks like a perfectly reasonable line. I'm going to make a form out of it. A couple of things I want to alert you to. I kind of did this just because my brain has been programmed to do this over many years. But note that the first point and the second point line up with each other. If we were to now take this line, and we're going to use a method that turns it into a surface by spinning it. Now, if we had this point over here somewhere, it would create kind of an open surface. But as it's set up right now, where those 2 points are sort of on the same axis, it should generate a closed surface. So up here in these menus at the top of the screen, you can see there's a curve menu, a surface menu, and a solid menu. Those are like your go-to menus for basically like making stuff in Rhino. They're going to kind of have most of the functionality that you need to model stuff. So right now we want to probably go on the surface menu because I had mentioned just a second ago that I wanted to make a surface. So if a surface is what you want to get out of the operation, you probably will want to try the surface menu. It's a good sort of rule of thumb. I'm going to use the Revolve method, okay? So the Revolve method, you basically define the start of the axis. In this case, I think actually the front viewport is where I want to define the axis. So I'm going to click on this point right here. Now that's the start of the axis, and then the end of the axis should probably be somewhere over there. And that's just because I kind of pointed, as I pointed out to you, I put those 2 points sort of lined up to each other, anticipating that I would whoosh that around in that direction. Can we do it in other directions? Absolutely. Interesting things will happen. But let's do it the uninteresting way first. So then, after I have a start and an end to the axis, it asks me for a start angle. You can do a revolve partially and make it just like a fan or a shell. We actually want to do a full circle, so I'm going to click the full circle box here. And you can see it did something. Now, I can't tell exactly what it did because I have not sort of set up my viewport yet, so I'm going to hit Control, wait for that to come up, the menu, and select a sort of more shaded viewport. So that's cool, fantastic. So this looks like we've jumped straight ahead to kind of closed polysurface. I'm going to go ahead and just make this as an open polysurface just to show you, or an open surface, rather. So if we go ahead and, oh, by the way, did everyone see how I didn't like how that point was, kind of coplanar to the end point down here? And how did I do that, everyone? I clicked it, and I drag it. So it's that easy. So any point on a curve line, you can kind of manipulate post drawing. So I deal sometimes with students who have, for some reason, a lot of anxiety about the curve function and not sort of getting it right. And my advice to that would be, don't bother getting it right because you can just move the points around after you make the line. and then you can get it exactly the way you want. When you're in the middle of an operation in Rhino, it's not a great time to sort of go back and, question your actions. Rethink your life, maybe. I don't know. So let's see. I'll just do the Revolve method again here. And again, it's asking me for a start and an end axis. When I'm doing these start and end axis kind of functions, it's a really good time to sort of glance at all 4 viewports and just make sure that it's here, 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 here. Because obviously, if it's not where you want it, it's not going to turn out the way you like. And so in this case, I can also do a full circle here. And so now this has produced an open polysurface. So if I go to select both of these things, it says 1 curve, 2 surfaces added to selection. That sounds about right. I could 2 surfaces. So sometimes this will say whether something is an open surface or a closed surface. And so if we click this individually, it is reporting back that it's an open surface. So this little sort of readout down here can be a good tool to kind of just know what you're dealing with. OK, so now we've got kind of like a point. We've got a surface, an open surface, and a closed surface. So that is that. And now we're going to take it kind of 1 step further, and we're going to maybe think about these as objects that we would like to 3D print. So that is going to involve a couple of things. We're going to go into the Mesh menu. And as you guessed it, the Mesh menu is where you will find most of the functions in Rhino related to polygons. As I said, is Rhino great at dealing with polygons? No, not really. But it's fine for certain things, and this is one of the things it's OK for. So we're going to basically pretend that we're making a 3D print. And I can go ahead and just make a mesh right here in Rhino. This isn't exactly the workflow that we would use if we were 3D printing. But we'll go ahead and go with it. Now, fun fact, this open form that's a single surface. Let me do my zoom selected thing again. OK. So is this form, is it 3D printable? No, no, it's not. I can certainly show you how to make it 3D printable, but 3D printable objects have to have like a thickness, and this is literally just 1 surface that doesn't really have any mass. So, and that's because it is an open surface. This one that's closed, can we 3D print this one? The answer is yes, because it's fully closed around itself. I will promise, actually, to come back to making this 3D printable on a different day. I think we kind of need to work up, actually, to that a little bit with some of the other tools in Rhino. So I'll save this document, and we'll come back to it. So that being said, I think for my kind of comparison test here, I'm going to favor the object that is 3D printable. And I'm just trying to get maybe 3 of these on the screen at once. And I don't think we need that. So what we're doing over here is we're basically going to convert these into polygon meshes. And so I can just click on any one of them, go to the mesh menu, and say from NURBS object. So I'm basically asking it to make a mesh. I can hit preview here, and so it gives me this like really sophisticated slider, fewer or more polygons. Sorry, that was sarcasm. It's a little, so this is a good sort of, this is what a high polygon model would look like. that's pretty much what you could expect for like a high poly model. And by the way, if you 3D printed that, it would probably look beautiful. Let's do a different version of that and maybe make this one even lower. So then we get our sort of low poly models. And just to be perfectly clear, there is nothing wrong with a low poly model. It's got a certain aesthetic. I mean, gosh, like low poly sort of models and things that look low poly are kind of like, I don't know, seems like they're kind of cool. And so, you know, it's a whole aesthetic, right? Like a lo-fi aesthetic. I don't it doesn't bother me personally if I see low poly something. I don't think it's low quality or, you know, anything like that. But it has a very different look. And I think particularly in, you know, my role as like a professor, I feel like I should tell you what the difference is and how you would be able to see it. And so in order to really see the difference here, I'm going to go into the rendered viewport. And let's see. You can see here the high poly model is like gorgeous. It looks like sort of this beautiful, uninterrupted surface. You know, you can't tell where the polylines are. That is good. This is less good. Which isn't to say that it's necessarily bad. It's just coming in with kind of artifacts, right? So artifacts from the process. Some artists really like that, and some people really are kind of into that. But yeah, it definitely gives you like a different sort of a different way of looking at, you know, the whole shape. And I think if this were 3D printed, you would even start to see some lines come up in this area. But certainly this sort of transition zone is kind of a mess. So that's basically, like, in a nutshell, you know, what the difference between low poly and high poly is. Now, if I wanted to take this high poly mesh and 3D print it, I could go into Export Selected. By the way, you can get an extra credit point for 3D printing something. So you could submit this to Shapeways and get your extra credit point. So we're not going to export it as a 3DM model. We're going to export it as an STL file. And keep in mind also, y'all, that I did file export selected, so it's not kind of bringing all the other trash from the file. And then you basically just hit export. Super easy. And then you'd be done. So let's kind of shift gears a little bit. And we got a chance to talk about the Revolve method, which is a really great and powerful kind of way of making things in Rhino. Let's talk about a couple of other surface construction methods. And so what we're going to start doing is we're going to start making stuff that could potentially go into an environment. And this is, you know, obviously geared towards the next two assignments, but, you know, also just more generally, we're going to be reviewing a ton of different techniques in Rhino. So probably the next sort of, you know, evolution of what we're doing, going from beyond, you know, making solid shapes from these prompts, is to really start thinking about using line tools and creating sort of custom surfaces and really getting into, like, you know, the stuff of Rhino. So I'm gonna make a boat. And I think I'm going to use the origin, the 0, 0 origin for now, just as a point to kind of anchor the whole thing. So I'm going to make a couple of lines just for my own sanity. And these lines are basically describing to me where I want some of the key elements of the boat. So basically what I just did is I marked a sort of center line to mark out how long I want the boat to be. And then this would be a sort of like, not the width of the entire boat, but this would be the width of the back. So not strictly necessary, but something that I kind of wanted to just do for myself. So now I'm going to make a control point curve, and I'm going to define a couple of things. I'm going to define the side of the boat, and I'm also going to define the bottom of the boat. Like there's maybe a ridge on the bottom of the boat. So I'm just going to draw a couple of control point curves. I'm in ortho mode. That's annoying. I can hit the shift key, or I can just turn off ortho, maybe. Maybe there and there. Again, I'm not going to get too obsessed with this because I can always change it later. And in fact, I can see here I probably might want to change this. I kind of wanted this to do that. And so that would basically be like the bottom of the boat, the part that drags on the seaweed. And then the side of the boat, we'd see from the top view, it would look something like... Notice, by the way, that I have all my object snaps disabled. If you're lined up with the grid, then in this case, I don't really need them. I will turn them on soon, probably. And again, I'm in ortho. I'm going to turn it off because I am making a boat. They're not known for being rectilinear objects. And so put that curve maybe right there. That's looking a little bit like a speedboat. I kind of want to make it more like a tugboat. So that's a little stouter maybe. Okay, so now I'm just still sort of kind of marking out my territory. Oh, by the way, somebody asked me after class, I think on Thursday, if I ever modeled or drew in the perspective view. And I would say, not really, no. I'm a sucker for the front, the right, and the top. You certainly can use the perspective view to draw lines and stuff, but you'd have to have your object snaps working really well. Otherwise, it has a tendency, the cursor has a tendency to migrate backwards and forwards a lot, and I don't know. So if you're struggling and you've been working mostly in the perspective view, you might want to consider backing off of that. Okay, so now I'm going to go ahead and I'm going to make kind of a back piece to the boat, which we need before we go any further. So this is the part where it might be a good idea to bring my object snaps back. So I'm going to enable my object snaps. And the reason I want to enable my object snaps is because I actually want to snap to something. And in this case, it's the end piece here. If I went into the front view, you can see it's kind of, obscured by the other part of the boat. So here, the object snap is actually kind of useful. And let's see. Oh, I'm in polyline. That's stupid. I wanted to make a curve. So let me try that one more time. And I'm going to make just kind of like a boat shape. And certainly, this is another situation where I definitely want the object snap to happen here. And it looks like you can see in the perspective view, it's like, oh no, maybe I want to go here, maybe I want to go here. This is definitely a case where I could use the perspective view to just kind of force the issue to select that point. And then I'm going to hit enter. And one last thing before I continue, I'm going to draw a line that goes from here to here. Probably not strictly necessary, but it's a good idea. And again, I'm really relying on those object snaps here to kind of get things done. Okay, so now I'm going to use a couple of methods. And you may notice, Meg, that might only look like a half a boat. Yes, it is a half a boat. Why am I drawing a half a boat? Because it's a lot easier to draw half a boat than it is to draw a whole boat. And I can draw a half a boat and just flip it and make it the other half of the boat, because boats are generally symmetrical. So that's why I'm doing that. So I'm going to go ahead and use some of these surface creation methods that we've talked about. So one really great surface creation method is the edge curves method. And basically what edge curves get, kind of its sort of input, is it wants 3 or 4 open curves. So it's a good method to use when you don't exactly have things like tied down. So I'm going to go ahead and show you. So here it says select 2, 3, or 4 open curves. So I'm going to select this one, nope, not that one. This is where this becomes useful. So I actually want the bottom one, because that's the bottom of the boat. And I can still select a couple more. I definitely want this side piece in there. And that should be all we need, actually. So let's see how that goes. Oh, hello. Let me turn on my ghosted viewport here. Well, hello. Hello, freeform curved surface. Nice to meet you. So yeah, so basically we just made this surface. And so before we sort of mirror this, I want to definitely fill in this back area. And I think also this is going to be a great case for an edge curves treatment, because it has, you know, edge curves. If we wanted to try it a different way, we could take these 3 open curves. So I'm going to select them. And you may notice something about these curves. They have one thing in common. They are all on the same plane. They're coplanar. So because of that, we should be able to use another one of my favorite curve surface generating methods, which is planar curves. So planar curves will basically take any group of flat shapes and fill in a surface. So I would argue it's probably my most used surface creation method, just maybe because of the way I work, but it's super powerful. Okay, so now we've got this stuff, and probably we can just grab these 2 surfaces, and I can use one of the transform methods, which is mirror. And it asks you for the start of the mirror plane and the end of the mirror plane. Now, the start of the mirror plane, this point seems like absolute, important to me, absolutely important. Yeah, it is. It's a really great way of defining, you know, where we want to kind of flip things on. So we'll go ahead and click that. And then as far as the end of the mirror plane, basically just wherever it looks right. Although hopefully if you've built things straight, you can kind of snap to that, 90-degree place, and you're in. And so now, wow, with 1 minute to spare, we have a boat. We still need lots of detail in our boat. We need a cooler. We need a bench. I think I'm going to give it a mast. Yeah, we're going to have some fun with this boat. And yeah, maybe even some creature features. Who knows? So I'll see you all on Thursday. Have a great week.